This time we're going to discuss systems of two linear equations. So our learning objective would be to be able to solve systems of equations algebraically and graphically, to be able to identify inconsistent systems of equations containing two variables, and to be able to express the solution of a system of dependent equations containing two variables. So what is a system of linear equation? It actually consists of two or more linear equations made up of two or more variables such that all equations in the system are considered simultaneously. So our aim is to find the unique solution to a system of linear equations that will satisfy all equations in the system at the same time. What are the types of linear systems? We have three types of systems of linear equations in two variables. And we also have three types of solutions. The first one is what we call your independent system, which has exactly one solution pair. And that solution is actually the point of intersection of the two lines. The second one is an inconsistent system, which has no solution. So the result would be two lines which are actually parallel and does not intersect. And the third one is the dependent system, which has infinitely many solutions, wherein the lines are coincident. So they are actually the same lines, so every coordinate pair of the line is a solution to both equations. Now there is what we call the graphical representation of its type of system. So this is the independent system, wherein we have one point of intersection, which is actually the solution set. We also have your inconsistent system, wherein we have two parallel lines, so there is no solution. And the last one here is the dependent system, wherein we have the solutions to be infinite because they are exactly the same line. So let's take the first example. We have here, suppose you are to solve the following system of equations algebraically and graphically. So the first equation is 2x plus y equals negative 8, and the other one is x minus y equals negative 1. So for the solution, we have, if you take a look, we can actually eliminate the variable x by adding these two equations. So when we do that, we have 2x plus y equals minus 8, and then x minus y equals negative 1. So that when you add 2x plus x, that will give you 3x, and y minus y is 0 there. The negative minus negative 1 is equal to negative 9. So you come up with 3x equals negative 9. Then we divide this equation by 3. So we will now have the following result. 3x equals negative 9 would be x equals negative 9 over 3, meaning to say x is equal to negative 3. Now, because there are two variables, we still have to solve for the value y. And how do we do that? We substitute x is equal to negative 3 and solve for y. So we have it here. We substitute the x value and then solve for y. So we try to use the first equation, but we can also use the second equation. So when x is equal to negative 3, what do we have? 2x plus y equals negative 8. So substitute negative 3. You now have 2 times negative 3 plus y equals negative 8. Meaning to say, when we solve this, that's simply negative 6 plus y equals negative 8. Then, adding 6 to both sides of the equation, we now have y equals negative 8 plus 6. So, negative 8 plus 6 will give us y equals negative 2. Meaning to say, the solution set is actually x equal to negative 3 and y equals negative 2. That is the write this as negative 3, the open interval, negative 3, comma, negative 2, open interval. This is a point on your XY coordinate system. So for the graphical solution, how do we do that? We can have the equation, the first equation is 2x plus y equals negative 8. And the second equation is x minus y equals negative 1. We're going to sketch 2x plus y equals negative 8. So when we sketch, we try to solve for y value. So you will have the following: y equals negative 2x minus 8. And then solving for the values of x and y, we have the following. When x is equal to negative 4, you can verify that you will have negative 2 times negative 4 will give us positive 8 minus 8 will give you 0. Similarly, if we try to solve when x is equal to negative 3, we'll have negative 2 times, this time you have negative 3 will give us positive 6 minus 8 will give us negative 2. You can do that one by one. You can actually verify these values, and we can also solve for the second equation, the values for y and x. So solve for the second equation for y, then sketch the graph. So if we try to solve for that, you can rewrite this as y equals x plus 1. So when x is equal to negative 4, we'll have negative 4 plus 1 will give us negative 3. Negative 3 plus 1, that will give us negative 2. Negative 2 minus 1, that will give us, negative 2 plus 1, negative 2 plus 1 will give us negative 1. And then negative 1 plus 1 will give us 0. And then when x is equal to 0, you will have 0 plus 1 will give you 1. 1 plus 1 will give you 2, and then when x is equal to 2, you will have 2 plus 1 is equal to 3. So we're going to make use of these values to sketch the graph. Now, how do we do that? Now have the following. So that's step 3. Now, we have this. If you take a look at the values first, let us see. When y equals negative 2x minus 8, this is the sketch here. Let us verify again. You have when x is equal to negative 4, you have this point. When x is equal to negative 4, y is 0. When x is equal to negative 3, y is, you have here, negative 2. When x is equal to negative 2, so you have y is equal to negative 4 here. It's negative 4. When x is equal to negative 1, y here is negative 6. And when x is equal to 0, y is equal to negative 8. And you can continue with that one. On the other hand, this sketch, y is equal to x plus 1, give us the following. When x is equal to negative 4, when x is equal to negative 4, so this is negative 4, y is equal to negative 3. So negative 3 is here. Let's see, negative 3 is here. Correct? Negative 3. So that one is negative. It's between negative 2 and negative 4. When x is equal to negative 3, so what do you get? This one, you have y equals negative 2. When x is equal to negative 2, we have x equal to, when x equal to negative 2, y equals negative 1, and down the line. So the solution to the system is the ordered pair, this one, negative 3, x is negative 3, y is negative 2. So you sketch that. Okay? So solving an inconsistent system of equation, we have the following example. Say x equals 9 minus 2y and x plus 2y equals 13. What do we mean again by solving an inconsistent system of equation? We're going to find out later on that there is no solution. If you take a look at this, substitute x equals 9 minus 2y to the second equation. Because it's already given that you have to get the value x, you can substitute for x. So you will have x plus 2y equals 13. And then you substitute your x minus 2y here. X equals 9 minus 2y here. So 9 minus 2y plus 2y equals 13. So 9 plus, you now have this is minus 2 and plus 2y. So it becomes 0, y equals 13. Therefore, you come up with 9 equals 13, which is not true. So this statement is actually a contradiction because 9 is not actually equal to 13. So the system therefore has no solution because you come up with an inconsistent system of equation. Note that this problem can be solved in two ways. So the second approach would be to first manipulate the equation so that they are both in slope-intercept form. That is, if you are familiar with the slope-intercept form, it is rewritten as y equals mx plus b, where m is the slope of the line. So what do we do here to be able to get the slope-intercept form? We try to rewrite the first equation into the following. That is, if we have x equals 9 minus 2y, we can divide both sides by 2 and come up with y equals negative 1/2 x plus 9 over 2. This is now of the form y equals mx plus b, your slope-intercept form. So to convert the second equation and express it into slope-intercept form, we have the following. The second equation is x plus 2y equals 13. So that can now be rewritten as 2y equals negative x plus 13. That is y equals, divide both sides by 2, negative 1/2 x plus 13 over 2. Notice that they actually have the same slope, but different y-intercepts. Okay? So meaning to say, different y-intercepts. So meaning to say, what we have, the lines are parallel and actually do not intersect. So we can make use of the graphical solution by showing that indeed these two lines do not intersect and that they are parallel lines. So if you have this equation, and we can compute for the value of x, for the value of y, by substituting some values of x, come up with the following. You can verify the values here later on. So we have these values, and when we sketch that, we come up with the following. The first one here is this. So in x is equal to negative 4, y is 13 over 2. That is supposed to be 6 and 1/2. So in x is equal to negative 4, y is this 6 and 1/2. When x is equal to negative 2, what do we have? When x is equal to negative 2, we have y is equal to 5 and 1/2. So negative 2, so you have 5 and 1/2. And x is 0, that is y is 9 over 2, that is 4.5, so 4 and 1/2. And down the line, you can also sketch this similarly by taking some values of x and solving for y and come up with this line. Okay. So what is the analysis now? So writing the equations in slope-intercept form actually confirms that the system is inconsistent, meaning to say there is no solution because there are actually two parallel lines and they do not intersect. So parallel lines will never intersect. So thus, the two lines have no points in common. For the third example, you're asked to find a solution to a dependent system of linear equations. So find a solution to the system of equations wherein you have x plus 3y equals 2 and 3x plus 9y equals 6. So for the solution, what do? We can eliminate one of the variables by adding the equations. And if we try to eliminate this one, your variable x, say we would like to eliminate the variable x, then notice that we have to multiply this by negative 3, the first equation. So multiplying that with the first equation by negative 3 would now give us, multiplying this by negative 3 will now give us negative 3 times x plus 3y equals negative 3 times 2, which will result to negative 3x minus 9y equals negative 6. So from here, we see that there is an infinite number of solutions because they're actually the same equations. This one is just, when you multiply this by negative 1, you come up with the same equation as the first equation. So the resulting equation is actually the same. It's actually a product of negative 1 with this equation. So there will be an infinite number of solutions that satisfy both equations. The other solution would be to rewrite equations in the slope-intercept form and come up with the value. If you have x plus 3y equals 2, so 3y equals negative x plus 2, and y is now equal to negative 1/3 x plus 2/3 when you divide both sides by 3. On the other hand, the second equation is 3x plus 9y equals 6. So you can rewrite that as 9y equals negative 3x plus 6. That is, you can subtract 3x on both sides, come up with 9y, and then divide this by 9 to get y. So you come up with negative 3 over 9x plus 6 over 9. Because of that, notice that this one can be actually rewritten as this, negative 1/3 x plus 2/3. So the results are the same. Meaning to say, they are the same equation. So the general solution to the system is x, negative 1/3 x plus 2/3. Okay? If you are given a system of linear equation and an ordered pair, how do we determine whether the ordered pair is a solution? So what do? We simply substitute the ordered pair into each equation in the system. And then we determine whether two statements result from the substitution in both equations. If so, the ordered pair is a solution. Let's take an example. So determine whether the ordered pair 5, 1 is a solution to the given equations. X plus 3y equals 8. 2x minus 9 equals 8. So you have these two equations. So you have to determine whether 5, 1 is a solution to these systems of equations. So simply substitute the ordered pair 1 into both equations and determine whether it will satisfy. So 5 replaces x, 1 replaces y. So 5 plus 3 times 1 will give you 8, which is correct. And then you have to substitute again on the second equation the value 5 for x and value 1 for y. You have that 1, and this is 10 minus 9, which is actually true. So mean to say 5, 1 is actually a solution to the linear equations. The x plus 3y equals 8, 2x minus 9 is equal to y. So that's the conclusion. For the graphical solution, what do? We again simply sketch x plus 3y equals 8 and also sketch your other equation. So you can rewrite x plus 3y is equal to 8 into this equation. and then again, try to solve for values of y when you substitute the following values of x. Similarly, you can sketch 2x minus 9 equals y by substituting values x and solve for y and come up with the following. So let's take a look. You are left to verify that these values are true. That is, when you substitute x, you come up with 8 over 3. So when x is 0, for the first line, you have this, x plus 3y equals 8. So when x is 0, you have y is equal to 8 over 3. That is equal to 3 and 8. So divided by 3. So 8 over 3. Then we have when x is equal to 2, that is y is also equal to 2. When x is equal to 4, you have y is equal to 1 and 1/3. And when x is equal to 5, y is equal to 1, and down the line. So similarly, when we solve for 2x minus 9 equals y, when x is 0, y is equal to negative, somewhere here, negative 9. When x is 2, y is equal to negative 5. So somewhere here. When x is equal to 4, it's equal to negative 1. So take a look, it's negative 1. When x is 5, it's equal to 1. When x is 5, it's equal to 1. When x is 6, it's equal to, we have 3. So this line represents 2x minus 9 is equal to y. As for the exercises, you're asked to determine whether the ordered pair 8, 5 is a solution to the following system of equations. There are some answers here. So all you have to do is to solve and determine whether you get the correct answer. The other exercises are given. So there's also a sketch that you can verify your solution. So can graphing be used if the system is inconsistent or dependent? Yes, in both cases, you can still graph the system to determine the type of system and solution. So, I mean to say, if the two lines are parallel, then the system has no solution and is inconsistent. If the two lines are identical, then the system has infinite solution and is a dependent system. So it will only have a solution if there is a point of intersection. Following are remarks. Some linear systems may not have a solution, and others may have an infinite number of solutions. So again, when does it have an infinite number of solutions? If the equations are actually identical. Some linears may not have a solution, that is, if the equations there are actually parallel lines to parallel lines. And in order for a linear system to have a unique solution, there must at least be as many equations as there are variables. But even so, this does not guarantee a unique solution. So we have here the summary: a system of two linear equations and two unknowns. If you are given such equation, a sub 1x plus b sub 1y equals c sub 1, a sub 2x plus b sub 2y is equal to c sub 2, then if a sub 1, a sub 2, b sub 1, b sub 2, c sub 1, and c sub 2 are constants, such that a sub 1 over a sub 2 is not equal to b sub 1 over b sub 2, we actually have a unique solution. If a sub 1 over a sub 2 is equal to b sub 1 over b sub 2, and b sub 1 over b sub 2 is not equal to c sub 1 over c sub 2, we have two parallel lines. Okay, you can also make use of this one to simply determine whether the line is inconsistent, say has no solution, whether it has infinitely many solutions, or whether it has a unique solution. So again, a consistent system of equation has at least one solution. So it is called to be independent system if it has a single solution and the two lines have different slopes and intersect at one point in the plane. So another type is what we call your inconsistent system, wherein we have actually two parallel lines. So the same on slope and different y-intercepts. So there is no solution at all. On the other hand, if you have a consistent system which is dependent, that is, they have the same slope and the same y-intercepts. Actually, that means to say the line actually coincide. So means to say it has infinite number of solutions. For the references, we made use of the following: Algebra and Trigonometry of the Department of Mathematics and Statistics, MSUIIT, and we actually have an online text also. It's a free text, so you can also take a look at this text. Thank you. We'll end with step 1.